I want to introduce Usoshi Chatterjee. She actually is from Ohio State. She got her her bachelor's and master's in food, ag, and bioengineering, which is actually my old department. And she's going to talk today about her work with poultry litter. So I'll go ahead and let you take it away.
Thank you. Thank you all for your time and for letting me talk to you about my research. My name is Usoshi Chatterjee, and today I'll be discussing utilizing poultry litter derived biochar with amendments for plant growth and pollutant removal. So what exactly is poultry litter? Poultry litter is essentially everything besides the chicken when it comes to poultry farming and poultry processing. So that includes kind of the feces, the feathers, the bedding, the stuff you can't really put in an air fryer. So by taking that excess material, it's traditionally reapplied back onto the land by at all of these farms and all of these farms, and this historical continuous land application of this poultry litter material actually creates some issues due to the continuous buildup of phosphorus and potassium in these soils, creating issues in terms of potential soil and water quality, leachate with excess nutrients, and so on. So by taking such a dominant industry's byproducts and converting it into biochar, we can kind of mitigate some of these challenges that are that we face with traditional poultry litter application. So how does this poultry litter turn into biochar? So there's a lot of different thermochemical processes that are traditionally used when creating amendments. However, the one of focus in this study is through pyrolysis, or thermochemical processing in the absence of oxygen. So this poultry litter is initially dried, then put through pyrolysis in order to create three main components. So this is a renewable energy process. So one of the main components that we get is syngas. So this can be used for a wide variety of bioenergy applications, and also bio-oil. So bio-oil also can be used for potential biofuel usage, as well as seed coatings, other agronomic purposes. But the main byproduct of focus is biochar in my study. This biochar essentially takes all of the leftover solid material, essentially the carbon and the minerals left over, into this kind of charcoaly, carbon-rich powder almost. This is kind of a better picture of what biochar looks like. And biochar is essentially a carbon-rich material that, instead of charcoal coming from your standard kind of coconut husk petroleum kind of base or coal, we're using a biological feedstock, in this case, poultry litter. So this pyrolysis process addresses some of the waste management issues with this material through reduction of the sheer amount of volume that some of these farms are able to produce in terms of poultry litter, while maintaining kind of a nutrient-dense, slow fertilizer material. So some ongoing applications of biochar currently are looking at enhancing soil quality and crop yields, as well as sequestering carbon and utilizing local resources. In our case, we're utilizing the resources from about 2-3 hours away in the Lower Eastern Shore. There are, again, some known components to this types of research, to this poultry litter biochar research, mainly that there is a kind of a robust nutrient profile with high amounts of phosphorus and potassium. And these nutrient benefits can be seen to have agricultural benefits in terms of crop yield, plant yield, But typically, when these are used in agricultural studies, they include only certain types of crops and certain types of other parameters like additions of compost and other blends of materials. So the unknown aspects that I'm trying to address with my research is looking at kind of the balance of the NPK ratio within this nutrient-rich material of biochar. We know what the nutrient content is. How do we direct that for exactly what our application needs are, whether it be for plant growth or for remediation? As well as looking at alternative nitrogen sources. So traditionally, traditional nitrogen sources include industrial chemical grade fertilizers like calcium nitrate, urea, your balanced NPK ratio fertilizers, but other materials also have lots of nitrogen, including wastewater and anaerobic digestate. So since this is already a byproduct that is forming, how do we combine this additional value-added waste stream into and merge it with the biochar? So additionally, we can see various remediation applications using these kind of information about the absorption capacity of biochar as well. So this leads right into the objectives that I'm studying overall, where I'm, for my first objective, addressing or quantifying the effect of poultry litter derived biochar on ornamental plant growth. So this is done through a Poinsetta study as well as a Marigold study. And then as all of the remaining kind of experiments are tied up, addressing the sustainability and impact of supplementing peat-based medias with biochar through various analyses. Peat-based materials, we definitely want to see if we can supplement, since a lot of peat-based materials are sourced from peat bogs, which are only in a few places around the world. They're slow growing and sequester a lot of the world's carbon. So by diverting away from that slower growing kind of peat and shifting to a more accessible and greater, more renewable feedstock, in this case biochar, we can address kind of that peat issue. As well as looking at objective number 2, how does the material at hand, biochar, have different absorption capabilities, and how can that be applied in both nutrient absorption and pollution reduction? So this is done through not just lab scale studies of static and kinetic tests, but also in greenhouse studies for turfgrass. So the ornamental study, again, kind of focuses on 2 different types of studies, the Poinsetta as well as the Marigold. The Poinsetta was run first with only really assessing various biochar concentrations, but the results from that indicated that, all right, we need to add a little more to the biochar in order to make it fully applicable. So we introduced various fertilizers and substrates as well. Since, especially during the Poinsetta study, as we'll get into, biochar can have, in poultry litter biochar has an extremely high phosphorus concentration and has potential phototoxicity issues if not addressed. So the methods for this study specifically, this was done in winter of 2020, 2021, with 5 different biochar ratios: 0, 2.5, 5, 10, and 20%, with 3 different fertilization frequencies using your standard greenhouse NPK balanced fertilizer with an NPK ratio of 17, 5, 17, at rates of weekly, every other week, and every 3 weeks, with 6 replicates. And analytics for pH, EC, nutrients, heavy metals were taken throughout the entire growing process as well as post-harvest. So we can actually see that with the inclusion of just kind of untreated raw biochar from poultry litter biochar, for all 3 fertilization frequencies, The lowest, or the control concentration, looks a lot healthier than the 20% biochar inclusion. And that it's pretty clear, the more biochar included, the worse the poinsettias look. So this isn't necessarily ideal when trying to find out good applications for this biochar. So we want to address, why is this happening? How can we still use this material since it has so many other types of nutrients in a more plant accessible way? Again, we can see kind of a closer up view of how this inclusion of biochar does affect the plants. The control looks much healthier with continued increasing amounts of chlorosis, stunted plant growth, etc., with the higher amounts. Also, again, reflected in the overall biomass, showing a decrease in biomass yield with inclusion of more biochar. But in order to understand why is this happening, why is including such a nutrient-rich, carbon-rich material affecting the plants so poorly? But by doing a deeper nutrient profile of this biochar, we can actually see that with a pH of an average about 9.5, that's much, much higher than the typical ideal of around 5.5 to 6.5 pH for plant growth. So there are alkalinity issues there which need to be addressed, as well as, since during the pyrolysis process, a lot of the organic material is volatilized, including a lot of the nitrogen, is volatilized into especially parts of the bio oil instead of the biochar. So once you have that loss of overall nitrogen in this material, you're left with the mineralized phosphorus and potassium, creating a much, much higher proportion of phosphorus and potassium in your biochar than is typical for the NPK, ideal NPK ratio for growing plants, which is usually between 3 to 1 to 2 or 7 to 5 to 7, again, depending on exactly what types of plant needs you're trying to address. And by looking at the raw or feedstock, the poultry litter itself, we can see that there is a reason that all of that we get this end profile in our poultry litter biochar. We can see right off the bat that poultry litter itself is much more neutral and well within the ideal range for growing plants. Makes sense why it is historically land applied back onto farms. And we also see a more balanced NPK ratio, since we see that the nitrogen components are much higher and not volatilized in this poultry litter. So the overall kind of takeaways from this poinsettia experiment were that this poultry litter biochar that I'm applying has an extremely high phosphorus and potassium and is very alkaline with a pH of around 9.4. So these two main components need to be addressed before going on to the next ornamental study. So that was addressed through a variety of different ways in the Marigold study. So marigolds are very common, very hardy, with a high markup value in Maryland and the general DMV area. And by including not just various biochar concentration rates of 0, 2, 4, and 8%, we're also including additional fertilizer types. So not just the standard greenhouse NPK, 17,517 NPK, but which also has not just nitrogen, but phosphorus and potassium, but a nitrogen specific fertilizer. So that is our calcium nitrate that we're focusing on. So ideally, that introduction of only a nitrogen fertilizer will balance that NPK ratio closer to what the plant needs are. We are also introducing various substrates. So again, we're trying to move further away from the peat-based materials in sun grow and moving more towards easily kind of collected renewable materials such as pine fines mulch and leaf compost. this material also has a higher amount of organic matter, so it's neutral, but slightly more on the acidic side. So again, the main kind of components to the Marigold study look at substrates, variability between batches, and fertilization types. Again, same types of methods were done with the marigolds as with the poinsettias. And we can actually see here that with the pH data, for all 4 biochar inclusion rates, the pH does increase over time, over the course of these 8 weeks. However, we see a greater increase actually with the 0% control compared to the 8%. And we actually see a lot more volatility in each of the waterings, pH waterings per week compared to the inclusion with the highest amount of biochar. Different treatments, and then looking more so at the biomass yield, we can see that again, for all of the treatments, with the addition of more and more biochar, now that we have that extra nitrogen component addressed, we have greater amounts of yield at 8% compared to 0% across the board. There was no significant difference between batches. However, between fertilizer inclusion, we can see that there is a definite difference between no added fertilizer, between how low that looks, and with the inclusion of our NPK fertilizer, and an even greater jump from our control to the 8% with our calcium nitrate or nitrogen specific fertilizer. So in this case, we do see definite improvement of plant growth, very different than the poinsettia graph, and we'll continue forward with addressing an additional nitrogen component. So again, supplemental nitrogen is needed, and we can see that poultry litter biochar is an effective amendment as long as we have that extra component to address that NPK imbalance. So this is objective 1, but objective 2 will kind of further explore this through understanding the deeper absorption mechanics and characteristics of biochar, in addition to utilizing not just our typical greenhouse fertilizers, but alternative nitrogen sources as well from digestate and wastewater. So this is kind of looking at the profile of stormwater runoff that will be addressed within the absorption experiment. So this simulated stormwater recipe will be our kind of main use model to understand pollutant removal of heavy metals typical to stormwater runoff in biochar treated areas. So overall, biochar has a lot of different applications with absorption. It can act as a slow release fertilizer, as we saw in the Marigold study, and also create different utilizations of effluent streams, such as, again, the digestate and wastewater, to create that balanced nutrient source, and continuing that on not just lab scale studies, but within the greenhouse. I'm looking at specifically batch and kinetic absorption experiments. So looking at understanding more of the mechanics of how this absorption occurs within the poultry litter biochar. Since there are different mechanisms, specifically focusing on adsorption of these nitrogen components to the surface of the biochar in order to, again, enhance soil fertility, reduce pollution, and customize that NPK ratio. So the absorption experiment has been adapted from Chicago and Dell, 2016, in order to assess, will the application of biochar help with the volatilization of when added to other treatments? So this has the biochar plus whatever fertilizer treatment, whether it be traditional urea, calcium nitrate, or digestate, as well as foams that are saturated with sulfuric acid and glycol in order to absorb that ammonia and see how that difference is with and without biochar treatment. The kinetic absorption experiment is done with a recirculating column, looking at the alternative nitrogen source, or in this case, digestate, and seeing how, not just with every pass, how much the biochar absorbs the nitrogen from the solution, but also how does the resulting leachate look? Is it cleaner? Did the biochar actually get everything out of it? And kind of seeing how that looks over time. And we can see, just though these experiments are ongoing, we can see that biochar can effectively absorb ammonia, as well as take out some of the dissolved solids with higher organic material in order to create a more balanced nutrient profile. So now that we already have the understanding of the biochar absorption, we're going to use those components and use it in a turfgrass mesocosm study. So mesocosm, it's just a medium scale study that's being done in the greenhouse. And these tubs, which have layers of gravel, leaf compost, pine fines, and then Kentucky bluegrass, will be either inoculated with biochar that's been treated or non-treated, as well as introduced with water or stormwater slurry, kind of seeing what the difference is with the inclusion of different biochar treatments. This is what it looks like if you were actually to go to the research greenhouse, as well as all of the tubs down here. And again, these are all the treatments that were developed with the greenhouse water versus the stormwater simulated slurry, as well as the treated or the saturated biochar and the non-saturated biochar. And the high and low concentrations, these are just to reference the minimum needs and toxicity levels for nitrogen for this Kentucky bluegrass. We want to make sure we stay within those limits and test those limits, how that grass interacts. So the overall kind of takeaway so far from this absorption study is that biochar can effectively absorb ammonia from nitrogen-rich solutions and further creating that balanced NPK ratio, as well as taking those excess nutrients out of solution. So it cleans the water that is, or material that is put in it. So this research so far has shown potential in poultry litter biochar working for not just agricultural and remediation purposes, but both together as well. So in order to continue this research, it would be great if additional nitrogen sources besides the digestate that I'm focusing on with my research would be analyzed, as well as assessing how different NPK ratios can be created for different types of plant needs. Since I'm focusing specifically on stormwater runoff, by applying this biochar remediation method to various types of sites, whether it be stormwater runoff or mine drainage, whatever it is, poultry litter biochar can potentially have use in remediation in these fields. And then continued applications in large-scale horticultural and agricultural applications. So I wanted to take some time and thank my lab and my advisors, specifically Dr. Lansing and Dr. Hassanein, as well as my committee members, Dr. Davis, and Dr. Felton, Dr. Lee Cox, and my undergrad Sarah and Brianna, as well as all of my collaborators in funding agencies. So thank you all for your time, and I'm open to any questions.
I have two questions. You mentioned picking marigolds because they were hardy and really common, and I might have just missed, why did you select poinsettias?
Similar, yeah, great
Same
question.
kind
Same kind of reason. They have great markup, especially in the DMV area. And specifically, since it was done around the winter time, even with the greenhouse, there's always potential stressors that are involved with winter experiments. So poinsettias are extremely hardy for that type of weather as well.
Okay, that might kind of answer my next question too, which is why you switched. Because you initially, did the biochar experiments and sort of as a pilot, and then we're adjusting the ratios and then retesting. And so I guess I was wondering why you didn't stick with the same species.
Yeah.
So you did the marigolds during the summer then?
Yes, and another reason is because marigolds are also, they have not just a shorter kind of term to maturity, but they also, due to their, they also have extremely similar growing characteristics and nutrient needs compared to poinsettias. They're both hardy, they both have an ideal pH range between, on the higher side, that was one of the main reasons they were chosen. Would they be more suitable to alkaline environments and not just be killed off? So they're more suited in can have an upper limit of around 8, basically. Through not just poinsettias, we can also see if marigolds, another type of crop or plant, can also have the same types of benefits. However, further testing, definitely, I would like to do repeated studies of the same types of plants in order to see how that changes. Yeah, great question.
Thank you.
So I know you were filling in some of the gaps about how you can use poultry litter derived biochar, but what are some other applications that you saw in the literature that help you narrow it down?
For the biochar or the poultry litter itself?
The biochar.
Oh yeah, absolutely. So I'm focusing mainly on agricultural and remediation purposes, but there's a lot of things that are being done with biochar right now. People are using it as a replacement for activated charcoal in biofilters. People are even grinding it up and putting it into different types of inks. And I think there were even some articles on biochar screen printed teas and everything. People are using biochar in different animal feeds since it helps with parasitic worms and everything. And even in structural materials, there's a lot of really interesting material science that is going on with biochar, whether it's doing kind of supplementation for concrete materials or just general kind of structure building kind of stuff. So, but pretty much since it's so high in carbon, it can be easily translated to a lot of different applications. It's just kind of how you process the material. Yeah, great question.
I might like to note for everyone that if you go to Lidl, you can buy German-made biochar containing toothpaste.
Wow.
Jet black.
Wow.
So, and minty, so try it sometime.
Interesting.
And it's biochar, not what is it?
Activated carbon.
Activated carbon.
Maybe that's.
You can also get deodorant, I think, that's like that too.
Yeah, so activated carbon is actually made usually from it's like charcoal mainly, but it's really expensive. And we use activated carbon for filtering, on water filter systems and other things, but it's expensive, right? So the idea is a lot of work has actually looked into substituting biochar for activated carbon in various things, but with biochar, it comes from so many different, poultry litter biochar is not usually what, it's here on the Eastern Shore, it makes sense. But what were some of the biochar sources that you saw kind of more in the marketplace?
A lot of the main types of biochar you'll see are from woody sources, whether it be hardwood, softwood, or straw kind of materials. And the initial feedstock itself also definitely has a different nutrient profile or kind of structure compared to poultry litter itself. So a lot of the commercial grade biochar products you'll see out on the market right now are not necessarily a reflection of every type of biochar. You can convert almost anything into biochar, but it doesn't mean that the biochar is going to be the same. So every feedstock, every biochar is different.
Yeah, and so someone says, oh, I used biochar in the fields and it worked great. Well,
What's it
where was
from?
your biochar from?
What type was it? What type was it?
Because that'll totally affect like what happened.
Yeah.
Well, if they ever make poultry litter biochar toothpaste, I will definitely approach you.
So, I think Andy, you had a question, and then we have a couple questions online as well.
Yeah, so the Marigold, you kept adding nitrogen and the biomass kept going up. You think if you just kept adding it, you could just keep growing more and more plants?
I think so.
It's kind of a surprising result.
Yeah, I especially since it was so different from the initial Poinsetta study, I think it'd be hard to extrapolate. I'm sure there's like some sort of max toxicity level, but without kind of testing those ratios, it'd be hard to say. However, again, this goes into the variability of like feedstocks. There's other literature that uses biochar in concentrations of anywhere from like 50 to 80% successfully, but it just means that the biochar is different. So hopefully with this processing, if I did like 100% or a 50% biochar, could actually work out. Yeah, definitely a
Interesting
future.
to explore that.
Yeah, absolutely.
Kind of interesting how strong of effect that was.
Yeah, and especially what that kind of max kind of.
Yeah, where does that go?
Yeah, because.
And then kind of as a follow-up on it, do you think that one of the detrimental effects that biochar can have is, and depending on the feedstock, like you were saying, is that basically maybe what it's doing is competing for absorption of nutrients, like versus the plant root? Is that, I mean, I'm not sure if you touched on that.
Oh, that is a huge component of this, and actually one of the main reasons I wanted to dive a little deeper into the absorption component.
Yeah.
So I'm pretty sure that's a lot of the reason why the poinsettias did not look the best with the higher amounts of biochar.
Right.
Since a lot of times when you have that biochar, a lot of people will charge it by adding it with like compost tea or have it like on the ground for animals to like. So
it's not as aggressive at binding.
Exactly. So when we have that raw kind of or untreated biochar, it still has all of those active sites completely open, and that's possibly why there were so many signs of deficiencies as we put in greater amounts of biochar, since it does have that competing effect. And once we add that extra nitrogen, we can kind of mitigate that, and that's what we saw in the Marigold study. So it will either help you or hurt you, depending on how you process it.
Yeah, so you had the compost, so you have lots of nutrients there, and the biochar, we didn't see the negative effects.
Right.
So we have a couple questions online. So Dr. Shamadahadi asks, have you determined nitrogen reduction rate / the capacity of biochar in the runoff discharge? And in other words, did you use field experiments to measure such reduction rates? And then he said, did you set up field attention to run the in reduction and runoff do the application of biochar in the field? Can you talk a little bit about what you're doing with basically the turf grass and the runoff experiments, specifically on the nitrogen reduction rate and maybe the stormwater runoff rates?
So that is kind of exactly what I'm focusing on with my turf grass experiment. And so, so I'll be introducing the stormwater effluent into the system. So I will be looking at the nitrogen throughout the entire course of the 6 weeks of growing this turf grass, looking at that nitrogen reduction with every watering, as well as looking at that nitrogen reduction over time with different biochar treatments, whether or not that biochar is treated with excess nutrients from that from the digestate or whether it is left untreated and applied to that turf grass, kind of assessing how the difference in nitrogen looks is definitely a key part of the study. The only thing is that since it's ongoing, I don't have exact results at this moment, but
I wanna go back to your, so you have nitrogen, you're adding organic nitrogen and nitrate in your stormwater mixture. And then go back to your tubs. And so these are actually in the greenhouse right now.
yeah.
Being grown, so it's not, it's a recirculating, so we're putting the stormwater mixture in the greenhouse instead of actually putting metals in the field.
Yeah.
And then collecting the runoff from there.
Yeah, these little kind of circles at the bottom, these are the collection spouts. So every stormwater event that I'll be conducting on these tubs, it'll kind of continue to look at that nutrient profile, including that nitrogen component, and see how it reduces, hopefully, over time.
And some of those questions you asked, so some of the biochar was sorbed with nitrogen, so it already has sorbed materials to it, and some is just regular nitrogen biochar, so unsorbed. And so looking at the difference between if you're adding sorbed biochar, which will help the turf grass grow better, versus unsorbed biochar, will there be changes in the metal and nitrogen retention of the stormwater mixture we're adding?
Yeah, so this is kind of looking at a dual component of agriculture as well as that phytoremediation component.
Yeah, it's interesting. Some of this came up with the last talk.
Jonas's,
Yeah.
the absorption of the biochar.
In this idea that it's the exchange sites, the charged surface sites, but then it's also a question of the actual matrix of the material, right? Like whether or not it has openings that ions can go into and be trapped. Maybe just weakly, it could be a very weak adsorption, right? But if the opening's large enough and can accommodate something to sort of right? So and maybe that's part of I don't know if that's something you could control after the fact, but maybe that's where the feedstock becomes important.
Exactly, yeah. And that actually was a question of mine I thought of as I continued to digest Jonas's experiments. I was curious as to what kind of biochar he was using. Well, it was activated charcoal, so it's probably from more of those kind of mined coal, petroleum, coconut husk, whatever type of feedstock. And that does have a more, has a more distinct and kind of standardized look and processing method to it than a lot of these biochars do.
Right.
And actually between batches I've seen some can have bigger pellets, some can have much smaller pellets. It's all kind of dependent on whatever process it's being run through, even not just feedstock to feedstock, but from pyrolysis plant to pyrolysis plant. You're looking at different parameters, different environments. It all affects that graphene structure in the carbon a little different. Yeah.
We have another question from Dr. Tilley. He says in the horticulture industry with ornamentals, there's a saying you can kill them with kindness, referring to the observation that most people overwater their plants. Did you measure or get a sense of the water holding capacity and the air porosity in the greenhouse Poinsetta study?
Yes, so I do have some results on bulk density and air pore structure for the biochar and biochar with the media used in the Poinsetta study, SunGrow. And we did see with addition of greater amounts of biochar inclusion, we had greater water holding capacity. So just from a practical standpoint, instead of numbers, when I would go to the greenhouse and it would be time for another watering and I would check the labels and everything, I could tell without even looking at the labels which ones had the higher concentration of biochar, since they were much heavier than the ones without anything, since they really maintained and held on to that water within that system. So
that goes against the kill with kindness.
yeah, you can
more if you overwater. Basically. Yeah, you don't need to water as much, which is great.
Exactly. So you can really kill them with neglect instead. So
Could they have been heavier because the plants were less healthy? and hadn't taken up the water.
That was a consideration, and that did definitely show towards the end harvest rate. However, we did see, even with not just like the extremes, the 0 to 20%, but the close kind of concentrations of 2 to 5. Those had similar kinds of, like we saw the plants in the similar sort of state, and the pot weight kind of reflected that as well. And during the initial point, the pictures that I showed, those were after 76 days. So they were starting to really suffer at that point, but there was a point where the majority of these plants were mostly healthy. But you could still tell at the beginning the difference between
You could
weights.
tell that you can't.
Yeah, exactly.
All right.
I don't think we have any more questions online. Okay, good.
So unlike some of the other biochars, I think poultry litter could probably be really variable.
Yes.
I mean, that bedding material can be everything from sawdust and peanut hulls and straw.
Now they're using
Yeah.
canvas, that's the
Yeah.
big thing.
So, I mean, and I would think the result of that is you're gonna have a very inconsistent material that some of it's more fibrous or more, has
Absolutely.
more bulk and more powdery. I've seen some of the powdery stuff.
Oh yeah, you've seen in the lab.
Can you speak to that? You know, I know you showed different batches, but did you see big differences in any of the characteristics of yours?
Within the same pyrolysis plant, it was fairly consistent.
Mhm.
However, there was a batch, and actually I can go back to that.
You like ordered a batch online for different.
Yeah, so it was still poultry litter biochar. It was just from a different supplier rather than the industry partner. And we can see, I'm not 100% sure what those processing parameters are and what exact type of bedding material they used. And we can see even just from that, we do have differences between the 9.9 and this is closer to 9.3, 9.4. We also have greater amounts of nitrogen still intact within this carbon matrix compared to the two batches that are mainly being focused on. So we can see a very big jump, so that heterogeneity is an issue. However, a lot of this is also in terms of how can we apply these absorption mechanisms and like plant growth applications as more so a method, and utilize, say, any type of biochar from whatever type of feedstock. And as long as you do the characterization, depending on how the nutrient profile looks, you could potentially use it for this application, this application.
What's interesting is that first batch, the one that we bought online basically, was less ashy. And so I think they had a less complete combustion process, so more stuff was left over in the biochar itself. So they were running it maybe at a lower temperature or a lower processing speed, so it was less combusted. Versus the ones at the end, they ran that thing to death. And so
Lots of
we had
ash.
no nitrogen left, all of it went. And so I actually think it was unoptimal parameters, maybe. It just depends on how much energy came out of these things, because this is an energy production process. You're doing process to get energy, byproducts of biochar, and you want to hopefully market that as well. And so it seems that they were running it very differently, which again,
Yeah, so we see a lot of ash, all of the nitrogen, all of the organic material, it's volatilized. So processing parameters definitely make a difference when it comes to your final material. So again, I'm not even sure if this biochar can really be a representative sample of most or all poultry litter biochar. It's just for this specific biochar, we found these characteristics, and this is how we are able to address it for various applications.
which makes when you read biochar literature for the students out there, be very wary of people saying biochar is this, because it's how did you make it, what was the feedstock, like just be wary of claims on biochar.
How you make it may be more important than
Oh,
what
yeah.
you started with.
Well, usually it's highly
It's a
variable.
growing field. There's people really interested, especially in the Eastern Shore, of using more biochar. Because the idea is we have poultry litter, but poultry litter, the nitrogen, phosphorus in the poultry litter is in this big matrix of all this other stuff that we're shipping back and forth, all around, because the phosphorus management tool, we can only put it on so many fields. So if we have it to biochar, now it's 20% less volume, and it's mainly the nutrients and that we need. Then that's a lot easier to ship back and forth,
The
right?
nitrogen phosphorus ratio gets worse, not better, so.
That's the problem.
But say you're taking that biochar to a different site where you have a lot of excess digester effluent or even a bunch of agricultural runoff, which also typically has high amounts of nutrients. You can use this biochar and specialize the application depending on whatever kind of what kind of characteristics your site has.
Or use it on soy.
Yeah.
If you're using it on soy, it doesn't need nitrogen, right? It just needs the phosphorus.
See, it kills the soils of
It might kill the
kills the
soil.
poinsettias.
You might, as long as you charge it, you take account of some of those active sites, it should be a little better.
So we know that ground soils generally need a lining effect, and this would do that.
It is
You gotta
alkaline.
be careful with how much you put down.
Yeah, as long as we avoid the Eastern Shore, we could definitely address some of those acidic soil challenges over here.
I should caveat my comments saying that I recognize your motivation was like for ag, and you're also not going to add stuff to your project. But one thing with the motivation being ag, you're sort of applying this to a perfect system where they're already fertilizing and they want to maximize this ratio to where they need it to be. But another potential industry might be sort of like the restoration industry, right? Like native plant enthusiasts are big into biochar right now as like a soil conditioner, not necessarily like a supplement.
Mhm.
And this would, like where you don't need as much nitrogen in the soil for native plants and like prairie restorations and things like that. This could be a situation where you could do that to get your nitrogen ratio down in those sort of systems.
Yeah, absolutely. And I think
Just in prairie restoration is what you're saying?
Yeah, I mean, that's like the big thing, right? When they do these restorations, they have too much nitrogen in the soil and all the weeds come up. But the native perennials and stuff don't typically want that high level of nitrogen, so they add more carbon into the soils. And you see this with like native plant enthusiasts, even in like backyard gardens, try to get the nitrogen, like more carbon into it. And they're probably buying all these like wood-based biochars, right? But this seems like it'd be like another like line of marketing for this waste byproduct.
yeah, absolutely. That's absolutely an ideal kind of application for that. And there's also been some, not necessarily with poultry litter, but poultry litter biochar, but with other types of feedstocks, biochar, doing application of biochar into prairie or wetland systems in terms of using it as a phytoremediation method and soil conditioner, but then also kind of harvesting the excess growth of those plants and then turning that back into biochar. And I'm not sure if you'd want to keep harvesting native plants. Probably
No, I think they do that naturally with like prescribed fire, right?
Yeah, yeah, exactly.
So burning it,
biochar.
you can make
You're
it
doing
biochar.
yeah.
All right, we are past our time, so we want to thank you, Shoshi.